Melissa, I love you. So big, my doom. That might sound like quite possibly the worst poetry in the world. Vogon poetry is actually the worst poetry in the world. But those are the first 4 big viruses that ever hit. Does anybody remember any of them? Yes. You're all showing your age. Yes. So Melissa came out in 1999 and infected at the time 20% of computers worldwide. You could probably argue at the time that it wasn't so long before that IBM said we only need 5 computers, that maybe there was only 1 computer that infected. But there were more than 5 computers, and 20% of them were infected. A year later was ILOVEYOU, which attacked tens of millions as well. In 2003, we had So Big. And My Doom in 2004 caused an estimated $38 million worth of damage. And to this date, I understand, the last time I checked was about a year ago, was still the fastest infection of any virus that we know. There's probably some viruses we don't know about as well. So I want to talk to you today about writing viruses for fun, not profit. And as with all good presentations of this type, I'm going to be one of those types of presenters and ask you all to stand up. All able people to. And if you would please repeat after me the delegate's pledge. I, your name. Pledge to use the following information for good. The clicker works. If I fail to uphold this pledge, I promise to commit to 200 hours of community service, offering IT support via Twitter. You're obviously not going to finish that line, so have a seat. Thank you. So today is mostly going to be a demo because we want to actually write one, not just learn about what viruses are. We probably know roughly what they are anyway. But I just want to quickly go through the components of a virus, what they do, and how we detect them, so that we know how to write one. So a virus essentially has 3 major things. It has an infection mechanism. So what is it? How is it going to actually get in? What is the payload that it's going to transmit once it does get in? And what's the trigger? What's it actually going to do once it's in? Is it going to wait? Is it going to act straight away? So with those 3 components, we have a virus. In order to detect viruses, we have various antivirus software that runs and does monitoring of systems in order to find out whether or not you've been infected. So one of those things would be to spread detection. Maybe your virus is infecting lots of files. That would be one way of detecting whether it's a virus, because that's one of their jobs. The other one is analysis detection. Is the virus that you've just uploaded to a system, is it starting to do an nmap? Is it looking for ports that are open? Is it looking at the local environment to see what it could potentially do in that environment? Is it stealing resources? While it's infecting lots of files and while it's scanning the local network, it's probably going to be having lots of file handles open. Or perhaps there's going to be lots of CPU usage or memory usage that's out of the norm. So the antivirus software will probably look out for things like that. So in order to escape detection, viruses have to take these into account, which we'll do today as we write our virus. So one of the issues with switching to an LCA slideshow is that some of your text gets cut off. But one of the things that viruses will do is they will try and evade detection. Now, to take a bit of a non-virus story, back in 2002, I believe, just after September 11 happened in the US, the head of security of the Israeli airport was interviewed and asked why they weren't installing backscatter X-ray machines, the ones where you've got to stand like that and watch this big zoomy thing go in front of you. And he says, well, to us, they're actually useless because we don't care if somebody takes water onto a plane and we don't care if somebody takes yogurt onto a plane. What we care is there a bomber on the plane? And in order to do that, they analyze people as they walk around the airport and they do more social observation rather than using technology to scan. They still use the metal detectors, and that was reliable enough for them. I'm not sure that's changed now, but that story made me think that in order to evade detection, you need to know how detection is being performed. So we don't need to worry about the Israeli security forces in the airports anymore, but from an antivirus perspective, keeping in mind what kind of activities would trigger a positive flag, we can avoid doing those in our virus. We can adapt and evolve. If we're never quite the same as we were last time, it's harder to detect. We can obfuscate ourselves if we can't even be seen. Maybe that's a good way of getting through systems. We can encrypt ourselves. Scrambling is not encryption, it's more like hashing, but I couldn't find a good analogy for encryption. But if the virus detector can't actually see what you are, but you're in plain sight, but you're obfuscated and encrypted and scrambled, then it's going to be harder to detect, like, is this just binary data that's an output from some kind of application, or is it a virus? We're not sure. How many people have installed through one of the mobile phone app store type things an application that has had slightly more permissions that they're comfortable giving away, but they thought, you know what, the convenience, I'm going to do it anyway. So Trojan horse is a really great way to install viruses because the convenience outweighs the Trojan horse. So maybe we can get it into a system by making it really, really compelling for somebody to install. Once we're in the system, we probably want to lay dormant. If you start acting straight away on infecting the rest of the system or trying to get information out of the system, then there's going to be a high correlation that something that just happened has caused this to happen. Whereas if we pause, then perhaps an antivirus software might detect that something's gone wrong, but can't really pinpoint the blame of it. And once we do start operating, take it slowly. Again, if we're not taking up a lot of memory, a lot of CPU usage, if the user of the machine doesn't know it's slowing down, you're more likely to be able to run that virus for as long as possible. For good, not profit. All right, that's enough of that. Let's write a virus. So I have, so the first time I ran this talk, like demoed it to myself at home, this virus will basically look for all PHP files in a directory and infect them. And then one of the payloads I had was to delete all the PHP files on a system. Don't do that on your host machine. If you want to write a virus, use a virtual machine. And also keep everything in Git. Anyway, so I've broken this down into a number of steps so that rather than typing and coding at the same time, which is very hard for my brain to do, we can go through some code in chunks and see it build up from nothing into a virus. So quite aptly, I believe, we're going to call this virus Boom. Hands up who's not familiar with PHP. Hands up who's looking at the screen going, I can't quite work out what this language is. Okay, so we've got a couple of little hands here. It's very C-like. You don't really need to understand the language. The principle is that this could apply to any language. Of course, PHP, as we all know, has tendencies to be it's got a history of being slightly more insecure, especially when you look at the history of PHP over the last 15 years or so. I feel I can say that as somebody who has only ever been a PHP developer and has seen the code. So essentially what we're going to go through is we're going to look at all the files that have a PHP extension. So glob gives us an array of all the files in the current system, and we're going to loop through each of those files. The first thing we're going to do is we're going to create a file handle in read mode to read that PHP file. So we want to infect a file, which means we could write it in, could open it in read-write mode and just inject the infection in. But one of the issues is that sometimes there's file locks. If the file is currently open and running in memory, then you won't be able to actually write to it while it's also open, but you can read from it. So in order to get through detection mechanisms that say, is there something dodgy going on in terms of accessing the file, and also in order to infect files that are currently open by another process, we're just going to open it in read mode. We're then going to open a second handle, and we're going to append .infected to the end of it, and we're going to open that in write mode. And the first thing we're going to do is we're going to write a line to the infected file, which is just a PHP comment saying file infected. Payload's not very exciting at the moment, but we'll take it in small steps. So we put that file, that line in, and then this while loop here basically goes through and says from the original file, copy a line, write it in, copy a line, write it in, until we get to the end of the file. So now we have two files, the original that hasn't been modified, and the new one, which is exactly the same as the original, only there's an extra line at the top that says infected file. So we close the script, we close the infected file. We then delete the original file that we wanted to infect, and we rename the infected file to the original file name. So now we've closed that loop, and the original file still exists in its same name with the infection at the top. Fairly rudimentary. Not a very exciting virus. I've also got a very complicated PHP script here, which I'll just run. So it outputs the numbers 1 through 9. Nice and easy. So if I run the boom file now, which we've just seen goes through and edits all the PHP files, one of the key things, I'll just clear that screen, one of the key things with any virus is you don't want any kind of output. You don't want to alert the user that something has just happened. And as you can see, nothing happened. I've got another bash prompt. How exciting. And then later on, somebody comes along and says, I need to run that example.php again because I can't remember the order of numbers between 1 and 9. And they get exactly what they're expecting. And nothing else has changed. Except for the fact that the example file has now been infected through having run the boom script. Exciting, right? We can all go home and write a virus now. All right, let's go on to the second step. So the changes that I've made here is you'll notice there's a comment at the top saying virus start. That's not because I'm forgetful and I have forgotten that I've written a virus. It's a marker, and we'll come to a reason for that in a second. And now we're wrapping the whole thing into an execute function. So into the execute function, I'm going to pass a variable which is the virus, and that's what we want to infect all of the files with. And we continue as before. We open up all the PHP files, and we read the original file, and we output the virus this time rather than just the text infected file. So this line here will take the virus parameter, the value of the virus parameter, and inject that into the new file. And we carry on and copy the original contents to the new file. We close the script, we close the infected file, we remove the original, and we rename the infected to the original, as before. Now, outside of this function, so this function hasn't actually run yet. It's just a function that's now in memory and can be used to infect all of the PHP files in the system. Outside of that, we're now going to get the contents of the current file. So double underscore file, double underscore, there is a PHP notation for the name, the actual path, full path and file name of the file that's currently running. So we're opening boom.php into memory. We're getting the contents, and we're putting the contents of that into a variable called virus. And here's where we use the virus start and virus end. So we use some substring positioning and trimming to say, I only want to copy everything from the first comment to the last comment, and you can see the virus end down at the bottom here. The reason for that is that when we inject the PHP virus into another PHP script, we don't want to be adding extra PHP tags, the open close tags at either end, because that's going to break the other script. So we now have a known context of the PHP. We know there is only the PHP code that we want to put into the new file. Everything outside of that is ignored, which helps when we come to replication later, because if there's a PHP file that's been infected that has this virus in it, we don't want the whole of that PHP script to also go into all the other PHP scripts, otherwise you're going to really break things. And remember, we don't want the user to notice what's going on. So if we run the example file again, now we're in the step 2 directory, so example hasn't been infected yet. If I now run boom, again, nothing happens. And if we look at the example file, we now have the virus start, we have the function. So this is the code that was in boom.php, which boom.php read from boom.php into a variable, and then used the execute function to inject into all the other files in the system. So we've now got a self-replicating virus. The virus doesn't need to know what the virus is, because the virus is the virus. Correct. All right, next step. So at this point here, we're still getting the virus into the execute function at the top there. We were talking before about encrypting the virus. We don't, like at the moment, that this bit here as well. Now, if you do want to write a virus, an antivirus checker finding the text virus start might have a hint of suspicion. So what we're going to do is we're going to scramble all this. We're going to convert it into something that cannot be decoded very easily by a third-party system that doesn't have all the information that is required to decode it, so it doesn't really know what it's looking at. So in the middle here, where before we had infection equals virus, we're now going to say infection equals encrypted virus. So we're calling a method there, or a function there, called encrypted virus. Let's jump down and have a look at what that does. Another caveat here, if you're writing secure software and you need to encrypt data because you need to keep it secure, don't use mcrypt. If you're writing a virus, you don't care. So we're going to use encrypt. So we need, and for those of you not familiar with encryption, you have like an initialization vector, which is basically this random thing that is used to make sure that the data you're encrypting is encrypted with a key that nobody else can really guess. And we're going to be using Rindale 128 and CBC mode, which is basically the algorithm and the mode that the encryption happens in. You don't need to understand how that works in order to be able to follow this code, because all we're going to see next is that we use the same parameters for decryption. So we create ourselves a key. We work out what the initialization vector size is, what the initialization vector is, and then we encrypt the virus. So the encrypted virus takes these variables, these parameters here, and the key and the virus and the initialization vector that we just created. And then we want to inject that encrypted virus into the file. So we don't actually want to decrypt it at this point. What we want to do is generate PHP that will decrypt the payload that we've just created. Does that make sense? So we're going to base64 encode all the data. So we're not inserting binary directly into PHP, which again could be a flag for antivirus systems. So base64 encode them. And then we're going to create a string, and the string is basically going to be, when looked at, PHP code, which takes the encoded virus, the encoded IV, and the coded key, so the base64 encoded versions we just created, and assign them to the variables encrypted virus, IV, and key. And then it's going to generate the PHP code that would then decrypt it using the same CBC mode and algorithm, and assign the value of the decrypted data into a variable that will eventually be $virus. But none of this is run yet. All we've got now is a string that if you printed it out onto the screen would be PHP code. We then evaluate that, because that allows us to run it the first time within this virus. And then we execute it, which then infects the other files in the system. But note that we're executing the virus that we've just decrypted, which will then get re-encrypted. Okay? If I get at least 12 nods, I'll continue. All right, so let's have a look at example. So example is still echo numbers 1 through 10. If I run the boom PHP file, we can now see, if I disable wrapping, that we have a different payload now as part of the infection. So we've got an encrypted virus. It's a huge big base64 encoded string there. We've got an initialization vector and a key, and we've got the PHP that will then use that information, which when decrypted will be the virus again. And then it evaluates it and executes it. Yeah? So if I do something like this, I'm going to create a new file called foo.php. In fact, before I do that, yeah, example has been affected. Just wanted to check. So I'm going to create a new file called foo.php, which is basically going to say hello to you all. So if I run that, we've got hello Linux Australia. That's probably the most complicated software I'm going to write today. If I now run example.php, we get the output we were originally expecting. Again, the output is consistent, it's the same, and the user has not noticed that anything has changed. And if I look at foo, we can see that it has now also been encrypted. And if we also look at example, we can see that example is encrypted. Maybe spot a difference between them. Payload is different every time. Because the virus injects files with an encrypted version of the virus, as opposed to encrypting it once and then infecting it with the same encrypted version of the virus, we get a different payload every time. This is another way of making it harder for the antivirus system to work out what's going on, because the payload is different. Has anybody here ever tried to remove an infection from a WordPress site? You know the first line is almost exactly the same every time, because they encode it once and they infect every file with the same thing, which makes it relatively easy to remove the infection. This way it's going to be harder, because you don't have the same thing to search for. You've answered my question already. The other thing that you won't have detected just yet is if we scroll down in example, we come to the end here, and now we've got a second infection. Anybody think of why that was? Correct. So example infected itself. In fact, if we run boom, we get cannot redeclare execute. So that will actually happen the first time because boom will always infect itself. It infected example, and example infected not just foo, but also example and boom. So boom has now been triply infected. So we need to find a way to not allow that to happen. Conveniently, that's step 4. And I'd like to thank you very much for progressing us onto that. So let's have a look at how we get around that. Various ways you could do it, but the way that I chose was basically to work out here, after we open the file, to find out whether the file has already been infected. So what I'm going to do is I'm going to grab the first line out of the potentially uninfected file, the source, and I'm going to take the file name of the file that I'm about to infect. I'm going to create an MD5 of that file name, and I'm going to check to see if that MD5 string appears in the first line of the file. If it does, then I've obviously infected it before. The advantage of this is that because I'm using an MD5 of the file name, that is going to be variously different for different files. So again, we don't have a static string to search for. Now, index.php in every directory is going to have the same one, but you're still going to get some variations in there. So if the file has not been infected, we then create the infected file, we write the checksum as the first line, we then write the encrypted virus in, and we copy the rest of the file from the origin into the infected file. So we're in the same position now, except we've now got that checksum. I think that's the only change I made to this one. Yeah. So, if we look at example, it's uninfected. If we run boom, and we now look at example, and disable repping. So we now got the checksum first, and we've got the encrypted virus in there. And then you can see down at the bottom that it goes straight into the original code. Let's create that foo file again, which just says hello. If I now run example as many times as I like, and we have a look at those two files, we can see that foo has a checksum, example has a checksum. They're different checksums. The encrypted virus values are different. And if we scroll down at the end of example, we have example's original code. We scroll down at the end of foo, we have foo's original code. We don't have double injections. So we've just written a virus that will infect every file in the directory. It will replicate itself when it runs any time within any of those. At the moment, boom will still break because boom is now infected because it didn't have a checksum, right? So it infected itself. So if I run boom again, that'll fail. If I can get out of Vim. Does anybody know how to get out of Vim? So boom still has an issue because we've got the plain text virus, and then it infected itself with the encoded virus, as well as putting the checksum at the top. So it only infected itself once, but it's still in there twice. So a bit more work to do in that respect, but it'll do for the purposes of this demonstration. So we have a virus. Let's have a look at an infection process. So I read a few years ago about an issue. Well, it wasn't an issue with WordPress itself, but if you had two particular plugins with WordPress, one of them with the other created a vulnerability that would allow you to upload an image that would then be processed by the PHP system as a PHP script. So rather than go through hundreds of lines of WordPress code to show you how that works, I just wrote my own little system. So we have, if we just switch over here, we have a very simplistic photo gallery. It's very exciting. It's not open source, but I can share it with you if you like. It's highly advanced. The idea when I wrote this was to try and cover as many security principles as we could, but still leave a little hole in there so I can actually infect the system. And we'll look at ways that that somebody might say, well, I'm going to put these mechanisms in place to stop people doing stupid things, but still have that hole. So let's have a look at the index.php file first. So if we skip down and ignore all the HTML, we've got the most interesting part in the middle here. And we're starting from this line here. So I'm going to go through, and outside of the document root, I'll go up a directory and then into the gallery images directory. So all the images are outside of the document root. It's good for a start. I'm going to find in there all of the files. I'm going to get those file names out into an array called images. And then I'm going to, no, I'm not, I'm getting them out individually into an array called image. And then 2 lines down, I'm going to call a showimage.php script. So obviously we can't load the image directly because it's outside of the document root. So I'm going to use a helper script called showImage, and I'm going to pass into it the file name of the image that I want to display. Yeah? So let's have a look at showImage. I'm just going to make that a bit smaller so it doesn't wrap so much. Is that easy to read at the back? Cool. So we're going to go through. The first thing I'm going to do is check that the referrer is the same. It's a bit of a throwaway security thing, but it's nice to have. So the main thing I'm going to do is I'm going to work out what the same file name is. So I can pass anything through in that query string, and this file could be called by anybody on the internet. So what we want to do is make sure that the file name that's being passed through is what we determine to be same. So if there's any characters that are not alphanumeric, a full stop, a dash, or an underscore, I'm going to get rid of them. So we can't come out of the directory, because we can't use a slash, and we can't put in any kind of weird characters that we wouldn't expect. I then assume that that file name represents an image that's in the gallery images folder. So again, I'm forcing it into that directory. It's outside of the document root, but it's in a known directory, and you can't target any other directory on the system. Then I determine the file type by using image magic to load that image and get the file type. I take that file type and I push it out to the browser. So whether I've uploaded a PNG or a JPEG or a GIF, I don't know, do we still use BMP files? I'm not sure. The browser's going to know how to deal with it, so it'll actually render as an image. And then I grab the contents. I did do a whole lot of jumping around to make sure this wouldn't happen. Sorry, I forgot that's how it works. All right. I thought I'd wait for you to come halfway down before I actually fixed it properly. Thanks. It was, totally. As was the glitchy opening slide, which absolutely caused panic. I loved it. It was great. So we're then going to get the contents of that image, and we're going to throw it straight through to the browser. And in terms of uploading these files, we have an upload script, which in some ways is quite similar to showImage. It makes a number of same sanity checks. We're going to make sure that it's of a MIME type that we actually want to display. So you can't upload a PDF, for example. So if the files array is set, that is, if somebody has uploaded something through the file upload mechanism, we want to make sure that the file type is one that we are happy to process. So we get the MIME type of the file that's been uploaded, and we see if it's in the array of acceptable MIME types. Assuming it is, we then work out using the same regular expression or the regular expression replacement, we remove all the characters we're not happy with, and the same file name is then used to grab the file from the temporary location that the web server has placed it in temporarily into the gallery images directory as hard-coded into that string. So again, the file that's been uploaded has to be an image, it has to have a same file name, and it has to go into a directory that we have predefined. Therefore, there's no way anybody can upload anything that we are not expecting, right? Thank you. So let's go in here, and I'm going to choose a file. The resolution up here is fantastic. So this file is called bread.jpg, and as you can see from the preview there, it looks like bread. It's also JPEG. So if I take that file, and I open, and I hit upload, we have a photo of bread. Thank you very much. Oh, hang on. No, that was another part. Sorry. Let's just, I always do this. I try and autocomplete bread.jpg when I'm trying to use Vim. Vim doesn't like JPEG files by default. Not sure why. So I think it's not in fonts. It's in files, images, bread.jpg. Brig. Wonderful. All right, let's just disable wrapping on that. This is what a JPEG file looks like. Does anybody here know the anatomy of a JPEG file? A couple of people. So the first line is basically like the metadata. It's the stuff the Australian government are allowed to store about you, the rest of it they can't. The second line onwards is all binary, and anything that renders JPEGs doesn't care what it is, it's just information that describes the image. So we don't want to change the first line, because that's what defines the MIME type header. That defines that it is a JPEG. We could change this, like a lot of systems nowadays, particularly OS X, for example, doesn't have extensions. It uses the MIME type and the header of a file to work out what kind of document you're looking at. So we don't want to change that first line. So I'm going to load step5.boom. I mean step5's boom.php. The astute amongst you, which is all of you, naturally, will realize that I didn't show you what step 5 looked like. It's basically got this change here, which is what stops me from breaking my whole laptop. So I'm only going to look for files that exist in vagrant www, which on my host doesn't exist. It's fantastic. So I'm just going to jump to the top here, yank all of those files out, paste them in down here. So we now have the bread.jpg here. The first line is still intact with the JPEG header description information. And then we go straight into the PHP code. And 108 lines later, we start with the JPEG content itself. Now, you sure can. Thing. It wasn't even me that time. Got it. Lovely. Before you go, it's still attached. All right, so we now have bread.jpg with a virus inside it. So I'm just going to write that one. Then we're going to go into gallery images, and I'm going to delete bread.jpg from here. So now if we switch back to the photo gallery, the file's gone. So the image is gone. So I'm going to go through that process again. I'm going to choose a file. Now you'll see this file here was modified at 1621, which I estimate to be now. So the preview still looks like bread. Nautilus, the file manager in Ubuntu, hasn't detected any change, even though the PHP is in there. Now, Nautilus, when it does a preview, doesn't execute PHP. So the PHP is actually being interpreted by the image preview library that's being used, which is interesting. Well, I think so. So I've selected that. I'm going to upload the file, and we have bread. But wait, there's more. So if we jump back into the www directory, we can now see that the index file has been infected. The upload file has been infected. And the show images file has been infected, all with different checksums, all with different encrypted virus payload values. Now, again, I recommend if you're going to write your own virus, don't use a variable name called encrypted virus. That's probably going to be a bit of a showstopper for you. But there's a way to change this. Use different variable names, whatever else, to try and make it less likely for an antivirus system to detect what's going on. So, with that said, we've pretty much got an infected system. What can we do with it? So here's some payloads I prepared earlier. The other thing that I did in step 5 was I added some extra code that would interpret the value passed through in the query string for the key eval. We all love eval. So let's say I go to eval equals hello world. And just in case you can't quite see that at the back there, I've made it a bit bigger on the actual rendered page. So what was passed in is eval equals echo hello world, and you can see in a little small text just underneath it, there's hello world. So the index.php script has actually taken the value of eval, evaluated, and done it. Not so interesting, but one thing you could do that might be a bit more interesting and a bit more useful to your devious evil ways is something like send an email. So you could deploy this virus across a whole load of machines and then create a mechanism by which they're all called with the ability to spam all of your users. Well, not users, I mean, they probably know who you are, but the people you want to spam. In the same vein as we can't edit the file in order to infect it, I came up with this one. So what we're going to evaluate is the command to put contents into a file, and that file is going to be called a.php. I'm assuming that a.php doesn't exist on the system, nor is it loaded in memory, which I can test by trying to hit it. But also, a.php is probably quite a vague file name. I could go more complex. And into that file, I'm going to put some PHP code, and the PHP code is set a string called header to the value of location : linux.conf.au. And then I'm going to put into the index.php the content set the header to the value of the string $header. It's a bit convoluted, but essentially what we're doing is doing a 302 redirect on the index.php. So having run that, index.php won't actually have changed yet. No Arabic? No. I'm fine with Arabic. It's wrapping that I don't like. There we go. So it hasn't been affected yet. If I now go to a.php, nothing happens because there's no output. But it's run the PHP that we just uploaded from the previous GET request. So now if I just quit out of this and bring it back to the foreground and reload the file, we can see the entire contents now of index.php is the redirect. And true enough, if I go back to my fantastic gallery that people have been paying $5 a week to use, it's high traffic. And the next time somebody goes there, they're going to get the LCA website. So I've now hijacked a whole domain. It's pretty cool. So if I can work out how to get my slideshow back up. All right. So we've written a virus. We've infected it. We're only going to use it for good. Remember that. So some payload ideas. We already looked at this one. So this is what the other thing that I added into step 5. If something comes through on the eval, then we're going to evaluate that content. Now, a lot of people will probably have eval disabled. And unless there's a really good reason to have it enabled, you probably should. So what other kind of payload ideas could we have? We can pass in a DDoS. And then we can have a whole swarm of computers grabbing an IP address and just making requests to it in order to take it down. But the most fun idea that somebody sent me was to create a JSON file on a server somewhere that every time you hit an infected site will go off and get the JSON file, which contains instructions in it, which means you can change your mind at any given moment. And you could, for example, have a switch in there that could do a DDoS, or it could do anything else you like. So we now have a farm of servers that are running your virus that will execute any command you like, so long as the instruction that's passed in through the JSON has been accounted for in the virus. And of course, one of those could be update virus. But why am I actually here telling you this? Who here is going to go away and write a virus now? I actually want everybody's hand up. So the main reason why I'm here telling you this is not because we should go out and write viruses and be nasty and make lots of money, because it's not for profit. But the main reason I'm telling you this is because if you think like a virus writer, then you're more likely to be able to identify the vulnerabilities that actually matter. We look every day, like when we went through that PHP code, the vulnerability there was when I used include. I included the file name, which then executed the PHP. I put so much control around everything else that I missed that small detail. And maybe if we think a bit more maliciously, we can pick those out more easily, or maybe not. But the other reason why I wanted to talk to you about this is because too often we get stuck into our day-to-day lives of development. And by taking a step back, thinking outside the box, and writing something that will hopefully never hit production, you can actually get a safe sandbox environment in which to play, in which you can try out new things that could potentially be malicious and give you a different mindset, but without actually the danger of being arrested, which I think is a great plus. So on that note, I would like to remind you of the pledge. I will be monitoring all of your Twitter accounts. I'd like to thank you for your time.
Because of Ben's otherworldly efficiency, we have 5 full minutes for questions. I'm sure there's a question in here.
How did you do the flickering effect on the title slide?
Most important question, yes. Katie and Liven had a screenshot and a glitch overlay. Yes. Somebody did ask me whether I was going to write a plugin for Impress, and I was considering it last night at 2 o'clock in the morning, this morning at 2 o'clock in the morning, and decided against it.
Any other questions? Has he covered viruses that thoroughly? Apparently.
Thank you very much. Thank you.